Hello class, I created this video to answer a few more of your homework problems. So it says we have a diamond and it can be classified as gem quality or industrial grade. 81% of the diamonds are industrial grade. Okay, so two diamonds are chosen at random. What is the probability that both diamonds are industrial grade? So if 81% of all diamonds are industrial grade, you would do 81 times 81, or 0.81, and I'll just square it, which is the same as doing 0.81 times 0.81. So we get 0.6561 is our first answer, right? Next, what's the probability that 9 are industrial grade? So it's the 0.81 raised to the 9th power, right? So it's a little, the chances decrease, right? So 0.1501, 0.1501. Let's just double check that I did that correctly. 0.150, and I rounded that 9 to a 1, right? All right, what is the probability that at least one of these 9 is gem quality, right? So remember, 81% are industrial grade quality, so that means 0.19% are gem quality. So if this is the probability that all 9 are industrial grade, the complement, right, 1 minus the 0.1501, okay, because this together has to equal 100%. I get 0.8499, so I guess 4 decimal places, so that's good, 0.8499. Would it be unusual that one of the randomly is gem? No, right? Because this is greater than 5%, right? So it would not be unusual. Check answer, 100%. Feeling good. Let's take a look at the next problem. Okay, in finance, one derivative is a financial asset whose value is determined from a bundle of various assets, such as mortgages. Okay, suppose randomly selected mortgage has a probability of 0.19% of default. What is the probability that the randomly selected mortgage will not default? All right, so if the probability for default is 19%, not default would be the complement, right? Or 1 minus, right? 1 minus the 0.19, which is 0.81, right? So 0.81. So an 81% chance it will not default, right? Part B. What is the probability that 4 will not default? Will not default, right? So if the probability that 1 will not default, 4 would be 0.81, whoops, raised to the 4th power, and that becomes 0.4305. Right, let's just double check. 0.4305, we rounded. And then the last one, what is the probability that the derivative from part B becomes worthless? That is, at least one of the mortgages default. All right, so we would do 1 minus 0.4305. And we get 0.5695. 0.5695. Check answer. 100%. That's what I like to see. Number 10. From the month of August, a certain city, 36% of the days are cloudy. Also in August, in the same city, 35% of the days are cloudy and snowy. What is the probability that a randomly selected day in August will be snowy if it's cloudy? So when I look at this problem, I'm going to just take a quick look at my sheet here. What is the probability of event E and F divided by the probability of just event E, right? So the probability of event F given E. So we're going to be given that it's cloudy, right? Because it says, what is the probability of snow if it is cloudy, meaning given that it's cloudy. So cloudy would be the E, right? So the E, the probability that it's cloudy is 36%. So 0.36 would be on the bottom. And the probability that it's cloudy and snowy would be the 35%. So P, E, and F would be the 0.35, and the PE would be the 0.36. So I would do 0.35 divided by 0.36 to get 0.972. 0.972. Check answer, and we get the 100% correct. Let's see. Okay, last problem. So it looks like we have a table here where we have the number of traffic fatalities for men broken down by age group and then by women. So it says, what is the probability that a randomly selected driver fatality who is female was greater than 70 years or older? So I want to open up this in, I'm going to do something I never do. I'm going to open this up in Excel. Let's see, I have to say allow, and then let's open up this file here. Give it a second. Okay, so when I open it up in Excel, this is what I get. Right? It's basically the same table, but in Excel. So now let's look at some of the questions. What I like about Excel is I can quickly use the sum feature, auto sum. Right? So if I want to know how many people there were total that were under 16, I hit auto sum and I highlight B and C, I press enter, I press auto sum again, right, press enter, auto sum again. I just want to make sure, ooh, see, that was a mistake. I want these two numbers, press enter, auto sum again, I want these two numbers, and let's continue doing it. So I'm just summing all of the under 16, right, 364 people, all of the 16 to 20-year-olds, all of the 70 and over, right, it's a total of 3,919, and then I want to sum all the men, press enter, and then I'll press this auto sum again for all the females. And again, just make sure you highlight this column, press enter. Okay, so now we have the totals. So back to the question. Probability that the driver is female, who was female, so I'm really only looking at this column, total of 14,488 females, was also over 70, right? So, and you know what, can we make this a little bigger? Let's blow this up a little bit. Okay, so female and over 70, so there are only 1,300 or 1,340 females. So if I do, press the equal sign and highlight 1,340 divided by this 14,488, press enter, that's the percent, right? So the percent of females that were also 70 and over was this 0.09249. So I'm going to enter that here, 0.092. And then we want the probability for someone that's greater than 70 was female, right? So here are all of the greater than 70, total of 3,919, and we want to know how many of them were female. So if I were to take the 13, right, so I press equals and I do 1,340 out of a total of 3,919, so I have to divide. Oops, I made a boo-boo. Let me escape. Let's try again. Press equals, 1,340 divided by this 3,919, right? That's E7. I press enter. So it looks like it's 34.2 or 0.342. Again, let's just double check, 0.342. And then the last part says, is a victim of a fatal accident over 70 likely to be male or female? All right, so again, let's take a look. I can delete this, right? Again, these were just my totals. So when I look at males 70 and over, so I'm going to check out the number of drivers that were male, right? So out of these 3,919 people over 70, there were 2,579 were men. So I pressed equals. That's the amount of men divided by the total population. And already I know the answer is the driver is more likely to be male, because if this is over 50%, then females will be less than 50%. We'll do the calculation anyway, right? I press equals 1340, which is C7, divided by this 3,919, right? So 34% of women, 65% of men get into accidents. So the driver is more likely to be male because the probability is greater than a half. Check answer. Boom, 100%. Thank you for watching.